Concentrating coders, it's Prof G with another first midterm challenge from our 0 to full stack SwiftUI course at Boston College. Now my students completed this as the second of 2 apps they built in class as their first exam. No coding assistant or other internet or old code example resources could be used. They could just use a single sheet of double-sided notes. And again, the reason I have those stipulations is the goal is to make sure everybody can survive code interviews. That's the kind of course this is. Now, anyone can pause after each question and try to complete the challenges, and my students will use this either to check their own work if they took this as part of their exam, or to prep for future midterm tests. Employers, my students are amazing. They're super brilliant. Reach out if you have any internship or hiring opportunities, and I'll pass them along. And if you're new here and you want to follow along with our course, you can find the entire playlist with well over 100 ordered videos that we use in our 0 to full stack course. That's at bit.ly/prof-g-swiftui, all lowercase. With that said, this is what we're going to build. It's a concentration app, a match game, we have an app icon, and a launch screen. And you see a set of 4x4 tiles. That's 16 tiles with 8 matching pairs. This white circle emoji indicates the back of a tile, and when you click a tile, you hear a flip sound, and you see what's on the other side. Now when you click a second time, your attempt to match 2 tiles is evaluated. If you don't get a match, you get a wrong beep, and you see a red button. But if you guess properly, you'll hear a correct sound and see a green button. Each tap is counted as a guess up top, and you see a status message that shows up or goes away based on an attempt to make a match. Now after each 2 guess attempt at a match, the buttons are disabled until you click on the another try button. Then the buttons are enabled so you can try again. And when you guess all the buttons, you get a play again option with a da-da sound. And if you click this, the game completely resets, including randomly reordering the tile locations. Now I will mention that there are even more efficient ways of building this app than the method that I'm going to show you. That method uses 16 different buttons, and the reason I'm not showing more efficient methods is because at this stage in our course, we haven't used some of these techniques. We will, and when that happens, we'll introduce ways to radically refactor our code. For example, our students are about to cover ForEach in their lessons. That's just one of the more obvious ways you can improve things. More on that later. But with that said, let's code! So I start by describing the game. The tiles will start flipped over. You'll tap a tile one at a time to reveal the images or emojis on the other side, and when 2 tiles have been tapped and flipped over to reveal their emojis, we'll evaluate whether or not a match has occurred. And if there is a match, the tiles will remain emoji side up. Otherwise, the tiles will flip over. Those aren't a match, and each tap is recorded as a guess, and a running total of the number of guesses is displayed. And the game is over when all the tiles have been matched. I put lots of screenshots in my exam so students know if they're on track, and we'll build the game step by step by answering the questions below. Feel free to pause and give this a try if this is your first time going through the exam. Now we'll create a new Xcode project called Concentration, and we'll find the concentration files in a folder at this URL, which is where we save all of the app resources for our course. We've got an icon to add, a launch screen to set up, and a bunch of sounds to drag into our asset catalog. So I'll launch Xcode, we're creating a new iOS app, and I'm going to name this Concentration. Make sure you create a Git repository because you're going to want to push this one to your personal portfolio. I'll expand the Xcode window, click on Assets, then click on App Icon. I've already downloaded my concentration files folder. I'll drag my icon into the first square in the app icon, then click all these other files and drag them over into the asset catalog. My 3 sizes of launch screen file are under launch screen. I'm going to press return, Command A, Command C to copy the name launch screen, then click the first icon in my project navigator, click on the info tab, click the expansion triangle next to launch screen, click the up-down arrow next to UI launch screen, and I'm going to change that to image name. Then double click in the value field and I'll Command V to paste. That pastes in the name launch screen that I copied. Press return, and you can build and run to check this out, but I'm pretty confident this is going to work. Now on to question 2. Let's keep track of the total number of guesses that a player makes using a variable called total guesses, which is initially 0. In Xcode, we'll add that with @state private var total guesses equals 0. And question 3 asks you to add a text view centered and pushed to the top of the app that says total guesses :number, where number is the total number of guesses that have been made. It should use large title font and black weight. So back in Xcode, I'll get rid of the first image view. I'll change the string inside of the text view to total guesses : string interp, passing in total guesses, setting .font to .large title and .font weight to .black. To push this to the top, we use a spacer with open and close parens, and we're ready for question 4. Here we want to create a value named game message. Now, we're not going to change the message in this text yet, but we're eventually going to hold various different messages that will change during the game. Not a match, try again. You found a match, you guess them all, or nothing at all. Now we'll eventually begin the game with an empty string in game message, just so that we can set up our user interface. We'll start this out by setting game message up to equal guesses in progress. This will eventually be blank. Now the game message is going to go inside of a text view, which is going to be in large title font in the center of the app. It should be in a box that's 80 points high, centered, and if the text is too large, we should shrink the font, but no more than 50% of its original size. So back in Xcode, we'll create the var @state private var game message equals, and I'll paste in the string guesses in progress. This will eventually be blank. And above the spacer, let me add another spacer. We'll add text passing in game message with .font large title, .frame height is 80, multi-line text alignment of .center, and minimum scale factor, which shrinks the font down to 0.5, is no smaller than 50% of its original size. So then we're going to create the first row of 4 buttons side by side so they look like the image below, and we're going to imagine that each button is a tile that can be flipped over when clicked. Don't worry about clicking and flipping yet, simply create those buttons. Now when the buttons are first created, they'll all display the white circle emoji to indicate that the tile is face down, showing the back of the tile so that you can't see the emoji that's on the front side, and store the white emoji in a constant named tile back, and use this when creating your buttons tile. Use the large title font on the button. Use the border prominent button style, set the button's color to white, which will initially not be visible because the app screen itself appears in white. We could deal with dark mode in here, but we're skipping it to reduce app complexity. And we also want to use the control size modifier to set the button control to large, i.e. control size.large. We haven't really used that much in class, but I just give you the code because I want everybody to use it. So back in Xcode, we'll set the constant up top. We'll say private let tile back equals, in between double quotes, I'm going to paste in the white circle emoji. Then after that first spacer, I'll create the first H stack, open and close curlies. We'll create a button with title and action, and it looks like I made a recording mistake with my pauses in here, so all the code shows up, but this is what we got. The title is going to be tile back. Tab over and press return on action. I'll put in a to-do comment here that says action, and we'll set the .font to .large title and .button style to .border prominent. This is looking blue, but we can set our .tint to .white and .control size to .large. This is what we want, but we're going to add 4 more buttons and use these same modifiers, so I'm going to highlight them and cut them out and put them underneath the H stacks curly. Then I'll copy my button code, paste it in 3 more times below, and we've got our 4 buttons. Now on to question 6. Create an array named tiles that will hold the list of emojis in the game. There will eventually be 1 emoji under each button or tile, but since we're starting out with 4 buttons, we're going to start with the tiles containing just 2 emojis, one for rocket, the other for chili pepper. I'll highlight and copy these bad boys. Then up top, add the array @state private var tiles equals, in between square brackets, paste in the rocket and chili pepper. Then back to the exam, and in question 7, when the app first runs, expand the size of the tiles array so that it has a second value for each emoji in the tiles list. So at this point, your tiles array should have 4 values, 2 rockets and 2 chili peppers. Put those 4 tiles emojis in a random order, and after we've doubled the emojis and put them in the random order, print out the tiles array in the console. Simply to check your work, and the emojis should be listed in their new random order with commas in between each element like the display below, understanding that this may change with each run since you're randomizing the emoji order. Now I do remind folks that sometimes preview is finicky and it won't show the results printed to the console. It's unclear why or when this happens. Sometimes it works and sometimes it doesn't, but if you build and run your app in the simulator, you should be able to print the results to the console and see it properly. You can ignore any other non-error messages, such as the print pollution, that isn't important for our work. Now, only if you don't know how to execute commands when an app first runs, and my students should because they've all worked with the onAppear modifier, simply set the tiles to the 4 emojis in this order when you initialize them. This will let you continue so you can try to answer additional questions below. So back in Xcode, I want to add my onAppear modifier below the VStack, so I'll cold fold the VStack, and below the padding modifier, I'll say .appear, and in between the curly braces, well, doubling what's in tiles is super easy. I can just say tiles equals tiles plus tiles. And then to put these in a random order, I'll say tiles.shuffle. Remember, shuffle will shuffle the original order in place. Then we'll print tiles. And actually, when I showed you the example in the test, I said to print it, but I didn't show the square brackets on the edges. If I wanted to remove the square brackets, I could just say print, and in parentheses, tiles.joined, and in parens use separator, passing in the separator string as comma with a space in it. If you didn't put that in, like I didn't put it in, I'm not going to mark you off. Let me expand the folded code and click to show the console, and look at that, we can see the different tiles. They look like they're in the first order, But if I option Command P to restart what's showing in the preview, I can see a new order for the doubled tiles. Nice. Now in a future lesson, we would probably create a struct for this instead of using multiple arrays, but we haven't covered structs and classes yet, so we're going to keep track of whether or not a tile has been flipped so that the emoji can be seen. Right now, based on what we know, we're going to create an array named emoji showing that holds a bool. There should be one element in the array for each button, which represents a tile with the emoji on the opposite side, and since all tiles are initially not shown, emoji showing should be initialized to an array of 4 false values. That means we're showing tile back, tile back, tile back, tile back, and not the emojis on the other side. Now here we'll say @state private var emoji showing equals, and some of you might have put between brackets false, comma, false, comma, false, comma, false, but we can also use this shorthand. Emoji showing is equal to capital A array, and we'll select the option to create an array with repeating and count, and the value that we're going to repeat is false, and the count will be 4. That'll give us the same thing, an array of 4 false values. So up next, in question 9, we're going to update the buttons so that when clicked, now remember, when clicked, we execute the button's action, and inside the action, we want to check if the emoji showing element for that button is false, i.e. there's no emoji showing, just the tile back. That's what it'll be at default when we start, and then when clicked, the emoji showing element associated with that button should toggle from false to true. Also modify the button title to change based on the emoji showing element for that button. So if we've got a value changing on a condition, the ternary operator might work well there. So if the emoji showing element is true, then show the corresponding element in the tile, which means the emoji for that button. Otherwise, show the tile back. Right now, the button title is just a tile back, so we're going to swap out a ternary operator in there. And also, we want to add 1 to total guess each time a new tile is clicked. The example below shows what the app should look like when the first and last tile have been clicked. And hey friend, if you find you're repeating bits of code each time a tile is clicked, refactor this code into a function called buildanapp that you can call for each button. Remember, it's possible that not all of the steps above can be refactored into a function, so any of that code would need to be outside of the function. Now a reminder at this point, once a tile has been flipped, clicking it again should not flip it back to display tile back, nor should it register another guess. We see our sample screenshot below. Let's head back to Xcode and set this up. So to work with a button click, we're going to set up the button's action. So we'll do that with the first button first, and I'll show you a little bit of the refactoring that I'm using right away. I want to pay attention to the index value of the button that I'm clicking on. So the one thing that'll be different in each button is instead of hard coding, I'm just going to say let index equals, and in this case it's going to be 0. That's our first button. And then below this, well, when do I want to allow the button to flip? That's going to be if the emoji showing at the index is false. So I can say if emoji showing bracket index, that'll be true. So to make it false, I can either set this equal to false or simply put the not operator, the exclamation point, out front. Then in between the curlies, I'm going to set emoji showing in brackets index equals true. So if the emoji showing for button 0 was false, we just set it to true. Now look how we're going to change the button title up here. I'm going to delete tile back, and I'm going to replace it with a ternary operator. The title of the button is going to change based on a condition. I'm going to say emoji showing bracket index double equals false. So if the emoji showing for this button in particular, which is button 0, is false, question mark, then I want to show tile back because the emoji is not showing, it's false, colon, otherwise. I'm going to show the emoji for that tile, which is in the tiles array bracket passing in index. And oh yeah, I'm going to get an error in here because the index value is defined below these curlies. It doesn't have the scope for this statement, this ternary operator up here, so I'm going to have to hard code the index in each of these buttons. I'll change the index in the ternary operator here to 0 and tiles 0. And then back down in the button action, well, if I just set the emoji showing to true, I also want to say total guesses plus equals 1, which just adds 1 to total guesses. Let's try this. Moment of truth. Let's click that first button. That's button index 0. Oh, and we get a chili pepper. Now, if you click it again, nothing is going to happen because of this if statement that we have in here. This prevents us from incrementing total guesses when we've already flipped over the tile and the emoji is showing. So now look what I have here. If I'm going to set my index for each button to a different value, index 1, index 2, and index 3, each button is going to have this block of code. So I'm going to highlight this code, cut it out, and refactor this by creating a function for it. Remember, we add our functions in our app just before the closing curly in the struct. So I'll say function, we'll call this button tapped, and in between parentheses, we're going to pass in an index value, colon, which will be an int, and in between the curlies, I'll paste in the code that I just cut out. Then where I cut out that code, I'm going to call button tapped, and for the index value, I'm going to pass in index. And now look at this, friends. What I'm going to do is I'm actually going to copy this first button that I'd set up. I'll delete the 3 buttons that I had below, and I'll paste in 3 more copies of this first button. And I'll just change the values that I've hard-coded. In the button title, those 2 zeros will become 1s here, and we'll say let index equals 1 inside this button's action. The third button will have the same things change but for 2, and the fourth button will have the same things change but for 3. Then I'll open the console. I've got the stuff printed here from previous runs, so I can Command K to clear out the console. Then I'll Option Command P to re-execute my code in the preview. I'll click this second button. It's the chili pepper. I can see down below that it is showing the right tile for the chili pepper. Excellent. Let's click the fourth button. That shows a rocket ship as expected. Excellent. And we can expose the third and the first icons in here too. We got chili pepper and rocket ship. We see the 4 button titles are now revealed in the same order as the titles that we printed out to the console. Outstanding. Trying to click a button again does not flip them back, and it does not register another guess. And that's exactly what we want. Now on to question 10. Now remember, we make 2 guesses before we check to see if we have a match. So we're going to want to keep track of each guess, and we're going to do this in an int array named guesses. This will initially contain no elements when the guess starts, and when you click on a tile button to reveal an emoji, we should add the index of the tile revealed to the guesses array. And down here, I offer you an example. I say in the example above, guesses should contain 2 elements, 0 and 3, since guesses have been made revealing the first and fourth tiles. Modify your code so that when you click on a button, if the emoji isn't showing, add the index associated with the button tile to the guesses array, indicating that a guess has been made using that tile. And I'll offer you a hint in here if you need to. Remember, if you need help figuring out how things are working properly at each stage, you can add print statements showing your output to the console. And below is the result of tapping the first, third, and fourth button. And also here's some output demonstrating what things would look like if you did decide to double check your work by printing out guesses and emoji showing arrays after each click. So the first, second, and fourth button would mean guesses are 0, then 0 and 2, then 0, 2, and 3. And you can see how the emoji showing array changes so that we have elements at 0, 2, and 3 showing as true, because we clicked on those and those have exposed the tile, they've exposed the emoji. Now in reality, we're not going to have more than 2 guesses at a time because we're going to evaluate a match. But first, let's get this working. Up top, I'll create my guesses array at state private var guesses, and since this is going to start out empty, we'll say colon and in brackets boolean equals, and then 2 empty brackets. And actually, I made an error. It's not supposed to be a boolean array. It's going to be an int array. We'll change that in a bit. So down here in my button trapped, I'll say guesses.append passing in index. This will eventually give me an error because I shouldn't have declared this as a bool array. It should be an int array. Below, I'm going to say print guesses, colon, string interp guesses. And below that, I'll also say print emoji showing, colon, string interp emoji showing. And bad me. Let's head up to that blank guesses array we created above. It's not an array of bool, it's an array of ints. Now let's try this out. I'm going to show the console and Command K to clear everything out that's in there. Then I'll Option Command P to execute my code. We double and shuffle our tiles, so we're rocket chili, rocket chili. I'll click the first button, and now the guesses array is 0. Only 1 value in there because I only made 1 click. An emoji showing is true, false, 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 because only that first emoji is the one that's showing. But if I click the third and the fourth button, my guesses are now 0, 2, 3. An emoji showing is true, false, true, true. Exactly what I want, and again, using print to make sure that you're getting the results that you expect can be an extremely useful coding technique. Prints are super useful for debugging. There's a lot more that we can cover in debugging in Xcode, and we will cover more in future lessons. But for now, let's head back over and conquer question 11. So we're getting there, but we're currently just flipping over tiles so that the emojis are not showing. What we want to do is, when performing button tap logic, check to see if the tap is the second guess. And if this is the second guess, then we want to call a function called a check for match. That will check to see if the index values saved as your first and second element in the guesses reveal the matched emojis in the tiles array. If the emojis matched, change the game message to state green check mark, you found a match, and if the emojis don't match, the game message should read red cancel X, not a match, try again. And examples of the 2 outcomes are shown below. The first one is no click, then 1 click for the chili pepper to show up, and then the second click for a rocket ship to show up. That's not a match, try again, but if I restart my game, first click is chili pepper, second click is chili pepper. On the second click, you always want to check for a match, and we'll show the game message, check mark, you found a match. So let's sashay over to Xcode and build this. So in button tap, we want to evaluate if we should check for a match, and we'll do that by saying if guesses.count double equals 2, open and close curlies. And if that happens, we want to call a new function called check for match. So above this function, I'm going to create a new function, func check for match, nothing between the parens, open and close curlies. Then let's call check for match in between the if statement we just made below. And how do we check for match? Well, we just say if tile and in brackets, guesses bracket 0 double equals tile bracket guesses bracket 1. My brackets are a little off here. Guesses 0 and guesses 1 are both inside of the tiles brackets, because remember, the guesses are just the indices of the buttons that are clicked. So what we're doing with the tile in here is we're checking to see if the tile at those indices is the same. And if it is, we got to guess. So if that's true, between the curlies, we'll set game message equal to just empty string for now, else in between curlies, game message equals empty string. And excuse me, it took me a second to find out that my square brackets were out of order. And now I'm just going to head back to the exam and copy the messages out there. Green check mark, you found a match. Or red cancel check mark, not a match, try again. And with the paste Xcode screwed up my double quote, but I'll fix that. I'm looking good, let me try that out. Click reveal rocket, you found a match. Then I'll option command P to start again. Chili pepper and chili pepper, once again you found a match. One more time, same place, rocket and chili pepper, and not a match, try again. This is working great. On to question 12. So also, when two guesses are made, meaning that the guesses array has two elements, we should do the following. Disable all tiles or buttons so that they can't be tapped again. Note that when the buttons are disabled, they will all, by default, show a gray background. And we should also show a button labeled another try using the title font and glass prominent. Now, conditionally showing a button means that we have an if statement inside of the code where we've got our view. Typically, that's inside of a VStack. We did that in Word Garden. We're going to do the same thing here. And if a successful match was made, the button color should be mint. And if it's an unsuccessful match, the button color should be red. The images below shows how things should look for a successful and unsuccessful match. None of the tiles should do anything if clicked, since they're all disabled and they show a gray background. You can see both of these options happen when the total guess is 2. And then for 13, we see clicking another try should re-enable the tile buttons, and if the guesses did not match, we should flip those tiles back over so that the tile back is showing. We're not going to do that if we did get a match, and in either case, we want to remove any guesses that are in the guesses array so that the new guesses can start. So this logic will ensure that we only have two guesses at a time. That's we check a match. We'll either show the mint button or the red button, and if we don't have a match, that red button is showing. We're going to flip over the tiles for the last two items that we guessed so that we're seeing the tile back again, not the emojis. We also want to set the game message to an empty string. And we also want to remove the default message from the game message that said guess is in progress. This will eventually be blank. Now, whenever the guessing is in progress, make sure that the game message is blank. Again, we see examples of the behavior below after a match is found and when two guesses are not a match. So let's build this. I'm going to head up top and set the game message equal to the empty string. And let's see, if we want to disable buttons, I'm going to create a Boolean value for this. I'll say @state private var, we'll call this disable buttons, and I'm initially going to set this to false. And while some of you might have put the disable button modifier underneath each button, hey, we can put it at the bottom of the whole H stack and disable everything in that H stack. So below control size large, I'm going to say .disable, passing in disable buttons. Nothing is disabled at the start, but if the guess.count double equals true down at our button tapped, well, I do want a disable button, so I'll say disable buttons equal true. And remember, I want to show that another try button if my guesses.count double equals true. So I'm just going to copy this conditional statement here. And since I want that button to show up conditionally below the spacer, just below my last spacer, I'm going to paste this in, and in between the curlies, if we're on a second guess, I'm going to add a button with the title key of another try, and in between the curlies, well, I'll put a to-do action in for now, but then I'll set the button style to glass prominent, and I'll set the tint, and hey, we want this tint to change conditionally, which implies a ternary operator. Now the condition, whether or not we're going to show mint or red, is going to be if we have a match or not. And hey, we've already written match code down here. It's in our check for match button. So I'm going to copy this code that says tile, and in between brackets, guess 0 double equals tiles, in brackets, guess 1 bracket. Then I'll paste that in the parens in the tint as the start of my ternary operator. This will be evaluated true or false. And if this is true, question mark, we've got a match, so our color should be .mint. Otherwise, colon, if this is false, we don't have a match, so the color should be .red. Now let's try this out. Chili pepper, rocket, not a match. Red button shows up. Nice. Rocket chili pepper, not a match. Once more, chili pepper, you found a match, and it's the mint button. Cool. Now that button is kind of tiny, and oh yeah, remember that I did say to set the font for the button to the title font. I'll do that. We'll try again. Things are looking great. And now remember what we need to do. If we click on the another try button, we need to change the disabled button. So we need to set disable button equal false so we can click those buttons again. And now remember, if we don't have a match, then we want to flip the visible emojis over. So we're looking at tile back. So I'll paste our check a match statement in here, but I'm going to change the double equal to not equal. So this essentially says, hey, if the tile for our first guess does not match the tile in our second guess, then we'll set emoji showing back to false. So we'll say emoji showing in brackets guesses bracket 0 equals false, emoji showing in brackets guesses bracket 1 equals false. That only happens if we don't have a match. Otherwise, the emojis are going to be showing. And underneath this, regardless of what happens, we want to wipe out the guesses so we can start trying to find the matches again, which are 2 guesses in a row. So we'll say guesses.remove all, open and close paren. We'll also set the game message equal to empty string. Let's try this out. Chili pepper, I found a match. Buttons are disabled. Let's click another try. The buttons are no longer disabled. The game message is blank. And we don't see this, but we removed all elements of the guesses array so we can start our 2 guesses from scratch. Rocket, same thing. Disable until we click another try. I'll option Command P to restart the code. Total guesses are 0, no emojis are showing. I've got a new scrambled set of tiles. Chili pepper rocket. Now we don't have a match, but watch what happens if we click that red another try button. We enabled the buttons, but we flipped over our 2 emojis, which is exactly what we wanted to do. Nice. Click again, 2 matching chili peppers. Click another try. These remain visible. Everything's working just as we want it. Guesses are counted. Matches remain. Those that aren't matches are flipped back over. Now let's move on to question 14. So I want to prompt the user to restart the game when all emojis are showing. And when all emojis are showing, which you should be able to tell via your emoji showing array, then all buttons should be disabled. The game message should state, you guessed them all. The another try button should not appear, but this time we want a button to appear that's labeled play again. That button should use the title font as well, glass prominent style, but an orange color, and clicking play again should enable the disabled buttons, remove any guesses from the guesses array, set the game message to the empty string, flip over all emojis, so all emojis showing are equal to false, reset the total guesses to 0, randomly reorder all the emojis in the tiles array, and at this point gameplay should resemble the images below, noting of course that your random order and guess order would likely be different. So let's give this a try. So we can do this a couple of different ways, but if I have my guesses count equal to 2, I'm either going to be showing the another try button, or if all of the emojis have been flipped over, I want to show the play again button. Now how do I check to see if all emojis have been flipped over? Well, I can say if emoji showing, remember that's the array that has true or false whether or not an emoji is showing, and if I say dot contains false, well, in between curlies, if there is at least one element that has the emoji showing, then I'm going to cut out all the code in here for the another try button, and that's when I want to show the another try. But if this condition emoji showing dot contains false is not true, that means every element in emoji showing is true, meaning all the emojis are showing, meaning I've turned over all the tiles, well then it's time for another game. At which point after this if statement I'll say else, open and close curly, and I'll add a new button with the title being play again, question mark, tab over to action, press return. I'll put a to-do for the action in here, but let me copy the button style for glass prominent and the font title, but I'm going to change my tint in here. It's not going to be conditional. It's going to say .orange. The play again button is always going to be orange. Now I also want to change the game message based on whether or not the game is over. So I'm going to copy this code up here where I check to see if emoji showing contains false. Then let's see, down here in the check for match function, this is where we change the game message. Now we've got a new condition that we want to check. We want to check to see if the game is over. So I'm going to put the same condition in here. I'm going to say if emoji showing dot contains false, open close curlies, and I'll put my else block in here because that's what's going to happen if the game is over. But up here, if the game is going to continue, that means I should keep guessing. So I'm going to cut and paste back in these two options here, either show you found a match or not a match, depending on whether or not our guess was correct. So up here, just to make this clear, I'm going to put in a comment that says keep guessing. But if we haven't passed that first condition, meaning every value in the emoji showing array contains true, well then in the else condition down here, our game message will say, you guessed them all. Then back up here in the button action, for the play again button, we'll set disable buttons equal to false. And it looks like I had another pause resume glitch, but we also have guesses.remove all and game message equal to 0. And now we need to set all of our emoji showing equal to false. And you know what? I'm going to grab the same code that I used in the initialization up here, emoji showing equals array repeating false count 4, and paste that down below. And we also want to set total guesses equal to 0, and we want to randomize our tiles again, so we'll just say tiles.shuffle. And so let me try to play a whole game here. So I don't have a match. And now I have a match, and now I have my second match. It says you guessed them all. I'm seeing my orange button. Currently I've got total guesses equals 6. My emojis are chili, chili, rocket, rocket. Let me click the orange button. Total guesses are back to 0. And I can see my first two are chili and rocket, so I must have shuffled things. Gameplay is working good. Let's head on to question 15. Now this says you'll notice that the center of the user interface elements doesn't remain in the same place. The tile, buttons, and the game message text view seem to be pushed up when another try or play again button appears. Do what's necessary so that the interface elements appear in the same place regardless of whether or not a button is showing at the bottom of the screen. And I give you a hint. Buttons can fit nicely into a space that's 80 points high. So look at these up here. You can see that the tiles and the message are pushed up a little bit when there is a button below. We want all the interface elements to be in the same spot regardless of whether there's a button there or not. The screenshots down below should show how things work if you correctly answer this question. And also note the examples below don't all show the clicks of a game, but they're meant to show that the interface elements remain in the spot if implemented properly. So let's make this happen. And this implies we want to make sure that we put a frame around the button to fit the button in, but then we want to use a frame of the same size when those buttons aren't showing, and we want to put something inside that isn't visible. So let's see. At the end of each button, and I'll start first at the end of the play again button, I'll add a frame with only a height, and we'll set the height to 80. Then I'll copy this modifier and paste it down below the modifiers for the try again button. But now either of these two buttons only show up if the guesses.count double equals 2. So I want to find out when this closes and create an else condition that has a frame of height 80 but has nothing inside of it, or at least something that's invisible. So I'll double click on the curly for guesses.count double equals 2. This is the end of that big condition, or it might actually be better if I code fold here, so why don't I do that? And after this if's closing curly, I'm going to say else open and close curly. And I'll put in a comment that says no button showing, but still take up 80 points with something invisible. So below this, I'm going to write a rectangle. We've created shapes in our lessons and in our challenges. Then I'll limit my rectangle with a frame modifier set to height 80. Now this rectangle is visible. Let's make it invisible. We'll say dot fill, and in between parentheses, we'll pass in dot clear. It's invisible, but we should have a space of 80 at the bottom. So regardless of whether the button is showing or not showing, we've got a frame of 80 down there, and that should ensure that our items that are above those two frames are not going to jump around. And we can play a few rounds here, and we can see the tiles remain in the same place, regardless of whether or not we have buttons below. It works for all buttons, and items don't even jump around if the buttons are disabled or not. Cool. Now let me expand this, and we'll head back to the test and look at number 16 in here. That's to add sounds. We added MP3 sounds when we added our assets to the project. Now do what it takes to play sounds when the following circumstances occur. When a tile is flipped, play the sound tile flip. When a pair has been correctly matched, play the sound correct. When a pair has been chosen that doesn't match, play the sound wrong. And when all tiles have been matched, play the sound ta-da. And note, if you play the tile flip followed by another sound, which will occur on your second guess in a two-guess pair, you're not going to hear the second tile flip because another sound will happen immediately after the first one right on top of it, but that's absolutely okay. So you'll only hear the tile flip when you make your first guess, but you'll always hear some sort of sound based on the conditions mentioned above. So let's code this, and my students have worked with audio before. We typically set this up by importing AVF audio, and then we create an audio player. So we'll do that with @state private var audio player : we'll declare, but not initialize it, an AV audio player. And the way we code this is we make this an implicitly unwrapped optional with an exclamation point afterward. And then just below the closing curly in the struct, we'll add our playSound function with func playSound, open and close curlies, open and close parens. My students probably have this written down on their sheet that they could use during the exam, since this is something that you might not commit to memory. But this is a reusable function, almost like a software Lego. And actually, between parens, I should be passing in sound name : string, so the name of a sound file is passed in. And first, if a sound is playing, we'll stop the play. So we'll say if audio player does not equal nil, double ampersand, which is and, audio player dot is playing, open and close curlies, audio player dot stop. Then below this, we've got a guard let statement where we set sound file equal to ns data asset, the option with name, and we're going to pass in the sound name. Else, if this doesn't work out, open and close curlies, return. But above the return, we'll put in a print statement: angry emoji could not read file name string interp sound name. Now, if this works, we're going to initialize an AV audio player, but to do this, it might throw an error. So we're going to do this within a do, open and close curly catch, open and close curly clause, and we'll set up in between the do clause, audio player equals try AV audio player. Select the option with data. We're going to pass in the data from the sound file. That's sound file dot data. If this works, we say audio player dot play, and it'll play our sound, but if it doesn't work, let's print out an error. I'll copy and paste this error statement up here, but I'll change it so it's angry emoji, error, string interp, error, localized description. That's the error thrown, creating audio player. And now let's play sounds when certain conditions happen. So in button tapped, right at the top, I'll say play sound and pass in the sound name tile-flip. Then up here in check for match, well, just above you found a match, I'll play sound, passing in correct, but if I don't have a match, I'll play sound, passing in wrong, and if we guess them all, I'll play sound, passing in ta-da! And friends, let's play a game and listen to these mellifluous sounds. And that sounds spectacular. Well done. Now we have one more question, question 17, where we want to make this a 16-tile 4x4 game. We want to update the game so that there are 4 rows of 4 tiles each. All of the tile buttons should work together for a continuous game of 4x4 concentration match. This is going to involve increasing the number of emojis in the tiles array. So for credit, add the following 8 emojis to the tile array. Then double them and shuffle them when the game starts, as you did in the example above. And only if you don't know how to do this, you can set this to the emojis when declaring and initializing your array, but repeat them. We should see 1 pair for each of the 10 emojis above, then complete the rest of the requirements to create the 4x4 concentration game. And I gave you some other things to remember. You're going to have a larger emoji showing array, and you may need to pay attention to the new size whenever you reset all of the values in this array to false when you restart the game. And if this works out, you should have yet another game that you've created using your Mad Swifty skills. Let's build and finish this up. So again, by the time this course is over, you would have done things differently. You would have used an array of structs instead of multiple arrays. You also would use ForEach instead of creating multiple buttons like we're about to do. But we're testing a third way through the course where you haven't learned all the techniques, and this method is going to work just fine. So I copied my 8 emojis to use, and I'm going to paste them up in between the brackets of the tiles array. I also want to make sure the emoji showing array has now got 16 elements in it instead of 4. And I know I use this array statement in other places, so I'm going to Command F and type in the word array. Sure enough, after play again, I want to make sure this resets the emoji showing array to an array of count 16 with falses in there. So that's taken care of. I don't have array anyplace else. And oh, let's see. Okay, what I'm going to do is I'm going to highlight my H stack with my 4 buttons in here. Now I'm going to end up with 4 H stacks with 4 buttons in them, and I want to put those inside of a single V stack. And I can still keep all of these H-stack modifiers outside of the V-stack, and they'll apply to all buttons in all H-stacks. So with my H-stack highlighted like this, and the modifiers outside of my highlight, I'm going to type a curly brace. That puts curly braces around this entire H-stack and indents this. And then to the left of the starting curly brace, I'll type V-stack, and I've just created a V-stack with all of my old H-stack modifiers applying to anything in the V-stack. Now I'm going to highlight and copy this entire H-stack with its 4 buttons inside of it. and paste it down below once, twice, 3 times, and I've got 16 buttons in here. But now I need to change the index values in all of these buttons. So I'll go to the second HStack here, and you can see in the button title area, I've got to change 2 of these numeric literals. Then I also have to change let index equal, so this HStack starts with 5. And actually, no, I'm wrong. I'm 0 indexed here. This HStack starts with 4, and then 5, 6, 7. Then the next HStack with 8, 9, 10, 11. And the last one with 12, 13, 14, 15. I think, friends, we're ready to play a game. Game over. Took me 42 guesses. Click play again. The game completely restarts. Things are reshuffled. I had a butterfly in the upper left-hand corner. Now it's a chili pepper. If you got this, congratulations, Swifter. If not, hopefully the solutions helped you understand how to make things work. Go through this as many times as you need to. If you're one of my students, you can come see me or TA if you got any questions. But remember, AI and coding intelligence built inside of Xcode does a great job of describing code. I hope you feel good about the skills you're acquiring. If you got tripped up, it's common early on in your study of coding, but hang in there. By the end of the semester, you're going to be full stack, baby. Keep hacking.